Hello, sir. My name is Sai Pan. I am a sophomore of VITAP. Today, I am going to present that means how to determine whether a system is stable LTI system or not. Using two problems, I want to give clarity on this. So, without any late, I want to start the problem. I want to start explaining the problem to you, sir. So, let me share the screen first. This may take some moments. Network is slow. Yeah. See, so for the given question is which of the following impulse responses corresponds to stable LTI system. So first of all, LTI system means linear time invariant system, and a stable LTI system has its own characteristics. So first of all, for a stable LTI system, H of n should be absolutely summable. That means modulus of sigma n equals to minus infinity to infinity. H of n should always be less than infinity. So if such is the case, then we call the system as stable LTI system. In the question given impulse response as h1 of n equals to n cos pi by 4 n u of n. As the time domain is n, we can say that the system is in discrete time series. So, so given u of n means unit step function, we all know that. So is wait, let me draw u of n. See, wait, sorry, I have drawn continuous time series. So, um, wait. Sorry for the late. Let us consider this as unit step function. For a unit step function, the value of u of n is always equals to 1 when n greater than or equals to 0. If such is not the case, the value of u of n is 0. So from here, we can conclude as the given impulse response is n cos pi by 4 and u of n, the value of u of n becomes 0 if n less than 0. So instead of n equals to minus infinity to infinity, we are considering the limits as n equals 0 to infinity, and we are substituting the h of n as n cos pi by 4, and we are eliminating u of n because u of n value is always equals to 1 when n is from 0 to infinity. So we are splitting the given n cos pi by 4 n as n into cos pi by 4 n. So we always know that the value of cos theta is always less than or equals to 1 because the value of cos theta lies always between minus 1 and 1. So let's consider the value of cos pi by 4 n here as some constant value, and now going to consider sigma n equals 0 to infinity to n. That means the value of sigma n equals 0 to infinity, n equals to infinity. Now the product is infinity into constant gives us infinity, so the value is infinity. So the system is, so it's having modulus of h of n value infinity, but this contradicts the fact that the system, if for a systems to be stable LTI system, it should always be less than infinity, but the value is infinity. So we can conclude the system H1 of n does not correspond to stable LTI system. That means overall, the given system H1 of n equals to n cos pi by 4 n u of n is not a stable LTI system. That means it is an unstable LTI system. So now we are going to solve another problem. Now the given impulse response is h2 of n equals to 3 power n u of minus n plus t. Here the point to notice is u of minus n plus t 10 is again a unit step function, but the value of n is given as minus n plus 10. We already know that for systems to be stable LTI, h of n should be absolutely summable. That means mod of sigma n equals to minus infinity to infinity, h of n should always be less than infinity. Now we know the properties of unit step function as u of n equals to 1 when n is greater than or equals to 0 and the value of u of n is 0 in any other condition. That means n less than 0. Now we are provided with the step function. The value of n is minus n plus 10. So substituting the limits, instead of n, we are taking minus n plus 1. Please let me write this. That means minus n plus 10 should always be greater than or equals to 0. Got my point? Then we are taking minus n should always be less than or equals to 10. Sorry, we are simply subtracting minus 10 from the both sides. So plus 10 minus 1 gets cancelled and minus 1 gets added to 0 gives minus 10 should always be greater than or equals to minus 10. That means minus n, taking n instead of minus n gives us n should always be greater than or equals to minus 10. Now we are multiplying with minus n on both sides give us minus n should always be less than or equals to 10. Now simply taking minus to the other side gives us n should always be less than or equals to minus 10. That means the limits of n is from minus infinity to minus 10. And the function given is 3 power n, and in these limits u of minus n plus 10 is simply we eliminate because the value of u of minus n plus 10 is 1 within the limits minus 10 to minus infinity. Now replacing n with minus n gives us, we have simply taken minus n instead of n here, and the limits we have taken from minus infinity to minus 10 as n equals to minus infinity minus we replace n with minus n, so n equals to infinity. We are changing the limits, upper limit as lower limit and lower limit as upper limit. Then 3 power minus n as a formula exists, a power minus n equals 1 by a power n. We have wrote in this form, and now we have a formula that sigma k equals 0 to infinity x bar k can be written as x bar k by 1 minus x when mod x is less than 1 and infinity when mod x greater than or equals to 1. But here x value is 1 by 3 is always less than 1. So we can solve using this x bar k by 1 minus x. Simply, as we compare both the equations, we can get x equals 1 by 3 and the value of k is minus 10. Now taking k power x power minus k means 1 by 3 power minus 10. That means 1 power minus 1 by 3 power minus 10. That means that can be written as 3 power 10, and 1 minus 1 by 3 gives us 2 by 3. Now the reciprocal gives us 3 by 2. 3 power 10 into 3 power 1 gives 3 power 11. That as the formula is a power m into a power n equals to a power m plus n. That means the value is 3 power 11 by 2. This value is less than infinity. So if in such a case, if modulus of n equals to minus infinity infinity, h of n is less than infinity, then we can conclude that the system h2 of n corresponds to stable LTI system. That means h2 of n, that means h2 of n means 3 power n u of minus n plus 10 is a stable LTI system. So that's all for this question. Thank you for listening.